Analysis and design of algorithms laboratory. Program 8. Design and implement C or C++ program to find a subset of a given set S is equals to S1, S2 till Sn of n positive integers whose sum is equal to a given positive integer d. So the task here is to find out the sum of the given set of integers. Out of given set of integers we have to enter the sum so that it will give you the output as the subset. So we have to identify the subset here for the given sum. So we'll start with hash include stdio.h and we define a function void subset which takes three parameters of type integer. So here we are declaring it, and we are declaring global variables in array x of 10, w of 10. These are two arrays of type integer. Then another two variables that we are declaring here is d and count is equals to 0. And now we start with void main, and here local variables we are declaring int I, n, and sum is equals to 0. I and n is nothing but the number of elements, to store the number of elements, and I is for the iteration purpose. We ask the user here using the printf to enter the number of elements which will be stored in n. Now enter the elements in ascending order. So we ask the user to enter the n number of elements, and using for loop for I is equals to 0 to I is less than n means it has to be stored in index 0 to n minus 1. So that's why we are using for loop here and initializing it to 0 till n. This for loop will run less than n when we are storing the elements in w of I. So this will be the array which will store the elements in an ascending order entered by the user. And we will ask the user to enter the sum. So whatever the array he would have the user would have entered, we ask the user to enter the sum which will be stored in d, the variable d that we have declared here. So it will store the sum d. And now for I is equal to 0 to I is less than n I plus plus, all the elements in the array will be added to find out the total sum of the array that we have entered. So that will be stored in sum. Now if sum is less than d, then there is no solution. Why? Because whatever the user would have entered, if it is less than the actual sum that is being calculated, means the total actual sum, then there no solution exists and we return from out of the program. Else we have to call the function subset and we pass the index 0, 0 and the total sum of the array. If count is equals to 0, initially we have initialized count is equals to 0, so obviously, initially here we have initialized the count is equals to 0. So when we call this subset function, we'll see the implementation of a subset function. So subset, since we have passed 0 which will be stored in cs, and another variable k which will be stored, the value of k will be 0, and the sum that we have passed is r here. So we are declaring one more variable I of type int for the iteration purpose. So initially we initialize the variable x of 0 is equals to 1. So since we have passed here 0, so k is the index that we have passed, so k is 0. So x of 0 is initially 1. So if csw of cs plus w of k is equals to d, means the very first element, the index 0, the value 0 plus the index whatever we have stored is equal to the value that we have that the user required, which is stored in d, then we return that value. So subset is equals to increment that particular count value. Since count was initially 0, so we will increment the count value, so count value, and then we print that count value. And now for I is equals to 0, I is less than or equal to k, I plus plus. If x of I equals 1, then we print that particular value. Means if it is only 1 that we have initialized, x of k is equals to 1, means only that particular element should exist in the sum. So in this subset, so we print that element. So this happens till for all the values of k. Else else, if cs plus w of k is not equal to d, then we have to recursively call the subset to identify the whether the subset summation uh, is the sum that we require or the user that has entered. If cs plus w of k plus w of k plus 1 is less than or equal to d, then subset we call recursively again subset, and we pass this cs plus w of k and k plus 1, the index we are passing, that is the next index to be checked to add the sum. And then r minus w of k, the whatever value that we have initialized it, so r minus w of k will be passed here. And now recursively we call that. And then if cs plus the r minus w of k is greater than, if it was less than, then it would identify all the subset which are less than the sum. If it is greater than the sum, then what has to be done? Greater than or less than. If it is in that intermediate value, then what, x of k is equals to 0. It has to initialize x of k is equals to 0. So when x of k is equals to 0, we again recursively call this subset function. So every time we call the subset function, the main identification of the subset happens in this particular if condition. If it is equal, then whatever the identified elements that is present in w of k will be returned to the particular program. So here you can see if count is equals to 0, means we have never entered this particular if condition. If count is equals to 0, the meaning of count is equals to 0 means we have never entered into this particular if condition. So it means that we were never able to find out the subset, means there does not exist any subset for the given sum. But in this case, if the sum exists, if the subset exists for the given sum, then count will be incremented. So if count is equals to 0, then what should be done? No solution, and then return. So we will ask the user to enter the number of elements. So if we enter 5 and ask the user to enter the elements in the ascending order, so the user will enter the elements in the ascending order. So once the user enters the elements in the ascending order, the program asks enter the sum. So the sum here is 9. The user enters, for example, if it is 9, then the subset, the elements which com- compose the sum as 9 will be printed. For example, here subset 1. So it is giving 1, 2 and 6. Why? Because 1 plus 2 plus 6 is nothing but 9. So we have got one subset. Again, if there exists one more subset for the same sum, then it will be printed. So it is 1 plus 8 is equals to 9. So only these two subsets exist for the sum 9. So this is the output of this particular program. Thank you.